Let us have an overview on basics of tourmaline. Tourmaline is a very common mineral. Most of the times it is found as gem variety, sometimes occur as black color, prismatic, sometimes greenish, pink. If you see this, this is dark green. Actually, in this photograph, it is appears as black. Actually, if we take it out from this mica schist, it will appear as dark green. This is light green. Okay, so most of the times it is a metamorphic mineral, occur in metamorphic rocks as well as pegmatites. So let's have a insight on tourmaline. This is a family of boron bearing aluminium cyclosilicate. Okay, cyclosilicate. In general, cyclosilicate is having Si is to O, silicon is to oxygen is 1 is to 3. Okay, so that contain alkali elements like sodium, calcium, lithium, iron and magnesium. Okay, so you simply you remember iron, magnesium, chromium, these kinds of elements always give coloration. Okay, whenever iron, magnesium, manganese, chromium, these kinds of elements present in any mineral, most of the times it is observed that they usually exhibit good coloration. Anyway, so notable members of tourmaline group include elbaite, scroll and drovite. You can remember, otherwise as a group you can remember tourmaline, but if you want to know further, these three are most common. There are so many other minerals as well which falls under tourmaline group, but these three is observed as most common tourmaline. Okay, which are commonly accessories in metamorphic and igneous rocks, especially in pegmatites. Okay, so definitely pegmatites. What are pegmatites? Coarse grained igneous rock. When that late magmatic situation appear, slowly cooling magma, what happened? Crystallization time is more, nucleosides, so it can grow more and more. So that is the reason such kinds of very well grown crystals of tourmaline is often observed in pegmatites as well, and these are highly appreciated as gemstones for their beauty and elevated hardness. As it is hardness wise, it is equivalent to quartz. As we know, quartz is having hardness, most scale of hardness is 7. Okay, like quartz, topaz, corundum, then diamond. Diamond is having the maximum hardness. Okay, so tourmaline and quartz is having similar hardness. Now, most interestingly, what is tourmalinization? Tourmalinization, it also refers to as a pneumatolytic modification of a pre-existing igneous rock in which boron rich, most important thing is boron. Okay, most important element in tourmaline is boron, Bo. Boron rich late stage fluids react with mineral assemblage of the primary rock, usually granite, eventually producing a rock consisting of tourmaline and quartz. Intermediate stages in this process showing alkali feldspar partly replaced by rosettes of tourmaline. So from this easily you can understand, most of the times alkali feldspar are metamorphosed, altered into tourmaline. So this kinds of alteration is called tourmalinization. Okay, by introduction of boron rich late stage fluids. When these fluids interact with feldspar, it will replaced. It will altered feldspar into tourmaline. So accordingly, all modification take place. Okay. So these kinds of pneumatolitic modification of pre-existing igneous rocks is called tourmalinization in high temperature condition. Apart from that, tourmalinization also can be referred as formation of tourmaline. Tourmalinization refers to the process by which tourmaline, as I have told, it is a complex cycloborosilicate mineral forms or become enriched in rock through various geological processes. So both the way you can understand, tourmalinization is process by which tourmaline occur or tourmaline gets enriched, or by pneumatolytic alteration process by which tourmaline replaced tourmaline replace feldspar. Both the way you can think. Now, as far as simple geological occurrence is concerned, the phenomena commonly found in mainly three environments: pegmatites, hydrothermal veins, and metamorphic rocks. Metamorphic rocks like schist, okay, most of the times mica schist or graphite schist. In these rocks, tourmaline often observed. Tourmaline typically forms in environments with boron-rich fluid and varying temperature and pressure condition. Okay, so the crystallization of tourmaline occurs as a result of the interaction between boron-rich fluids and the host rock. So every time, repeatedly, I am keep on telling that boron is very important. Now let us have a brief discussion on different geological conditions. As I have told, these three. Out of this, first one is pegmatitic tourmalinization. In pegmatites, what's happening? Is a particularly favorable environment for tourmalinization due to their high fluid content, especially boron-rich fluid, and slow cooling rates, allowing for the growth of large well-formed crystals. During this crystallization, boron-rich fluid, what it does? It infiltrates the surrounding rocks, especially that potash feldspar-rich portion are affected, and depositing tourmaline along with their minerals such as quartz, feldspar, and mica. Tourmaline crystals in pegmatite can range from millimeters to several meters in size. There are certain areas where huge tourmaline crystals are reported, even up to a meter or more size. Okay, and it may exhibit intricate zoning patterns or be included within other minerals as well. Okay, next is hydrothermal tourmalinization. Okay, first one is pegmatitic. It is like magmatic, you can understand for your understanding. Further, hydrothermal tourmalinization occurs when hot mineral-laden fluids migrate through fractures and faults in the earth crust. So these are fault or fracture bounded most of the times, micro cracks or large scale fault or deformed zone. In this zone, tourmaline often observed because of these kinds of fluid action during hydrothermal activity interaction. These fluids often originate from different sources like magma chambers, deep-seated hydrothermal system, and carry dissolved elements including boron, which precipitates out of the solution as tourmaline when conditions like naturally required temperature, pressure, pH is fulfilled. And this hydrothermal tourmalinization can result in the formation of veins or pockets of tourmaline within host rock, which may include granite, schist, or carbonate rocks. Because carbonate rocks, when it interact that boron-rich fluid, then if we see this tourmaline, it is a family of sodium, calcium, and lithium. So whenever that limestone or carbonate-rich environment prevail, there also tourmaline form. Okay, next is metamorphic tourmalinization. It is also very important, and for us, since I am associated with graphite exploration sometimes, so there I have noticed several tourmalines, huge. Sometimes at certain places there are some quartzo-feldspathic altered zones, and within that gemstone variety of tourmalines are being explored by other different agencies by using small scale mining activities. So these tourmalines can also form during metamorphism of existing rocks, particularly those rich in boron containing minerals such as mica or clay minerals. What happened during metamorphism? Such kinds of boron rich clay or mica, they gets dehydrated, fragmented, and from that fragmentation, chemical fragmentation or breakdown, boron released, and then recrystallization happens. During metamorphism, these boron-rich minerals break down, releasing boron into the surrounding fluid space, which can then crystallize at tourmaline under appropriate conditions. So metamorphic tourmalinization commonly occur in regional metamorphic terrain where rocks are subjected to enough high temperature and pressures over large areas. Mostly it is found in upper amphibolite, lower granulite, or sometimes upper greenish facies metamorphic condition. So if we consider this facies condition, it will come around 650 or 500 to 700 degrees Celsius, because that greenish facies or amphibolite starts at, if we see, amphibolite facies starts at which temperature? It is around 450. It persists up to 700 or more than 700. So within these kinds of range, most of the times tourmaline occur formed. So for timing, that is all about tourmalinization. In next video, we will be discussing about pyrites in graphitic schists, how graphite and pyrite coexist. For the so keep watching. For the time being, thank you.